The title of our experiment is called Falling Objects by Nancy Diaz and Clarissa Delgado. We are both students at East Aurora High School in Aurora, Illinois. We are both juniors and we are both 17 years old. Hypothesis. Do all objects really fall at the same rate? We'll be testing Galileo's theory of falling objects. To test this, we will be comparing the time it takes for two different objects to fall. We will vary their mass and the surface area. The rate of speed should be determined by the acceleration of gravity. For consistency's sake, we will also adjust the height in which we drop these objects, so that we are able to gain enough data to support Galileo's reasoning that all objects fall at the same rate. Background information. We believe that all objects do fall at the same rate, but we will support his theory by testing out different objects that are heavy and light. The height will remain constant throughout the whole experiment, therefore the results should also remain constant. And through his theory, it should make every object the same speed. Still, even though they have different masses, it will still be the same speed. The materials that we used in this project was paper and pencil to record our data, a scale to weigh all the things that we use like the masses, a stopwatch to time the fall of every drop that we did, the meter stick to measure the height of our drops, an iPad and an iPhone that we used to record, a tape measure also to measure the height, and the masses to include inside the box. See? These are some of our materials that we used. We also used a box which all the weight masses went inside of it. We measured the box and recorded it in centimeters, in 2 meters. And this is a setup of how we used it. We just put the masses inside the box like I had said. The experiment description. We tried out our experiment using objects around the house that are commonly used and easy to find, and then we used the timer to see if the objects are falling at the same time no matter the weight, considering that the height will remain as a constant. One will be dropping the object and the other partner will be taking the time with a stopwatch. If Galileo's theory is correct, then all times at the end of the project should be constant, no matter the mass or the size of the object. The experiment setup that we used to conduct the experiment was, first we had to find a rectangular box, like in our picture. 2, we weighed the box in the scale. The scale was in grams. 3, weight the scale that we will be using to check accuracy. 4, tape box to make sure the masses wouldn't fall out. 5, measure the first height that we will be dropping it. 6, position box for drop vertically. 7, drop box and use stopwatch to figure out the time. 8, add second mass and drop once again and measure the height and record the time. 9, add third mass, drop the box, measure the height and record the time. 10, we repeated steps 5 through 9 only at 2 different heights after the first one that was conducted. And then 11, go back to the first height measured and position the box horizontally. And then we repeated steps 7 through 9 2 more times. 13 was write down all information for all drops, including the weight, mass, height, and time, and put them in a table to have our collected data in an organized manner. This is a video of when we dropped our first box vertically, and the second video is when we dropped our box horizontally. The data collected. Every trial that we did was different. When we dropped the box vertically, the time decreased every time, and it hit the ground faster when the box mass was being increased. When we dropped the box horizontally, we thought it was going to follow the same pattern as when we dropped the box vertically. However, when we started dropping the box, we noticed it wasn't the same pattern, and the times were all different. Usually the second drop was higher than the first and third drop time. Results. Our experiment did support our hypothesis for the most part. The data for the most part is relevant to what we thought would happen. We dropped the boxes at 3 different heights, with 3 different masses, for an entire week. We then averaged our time for each drop that we did for each day. Dropping the Dropping the box vertically, results are found in tables 1 through 3. Every table is the same. The difference is the height in each trial, but each table is going to consist of first, second, third drop, the time, and the weight. We measure the height with a tape measure and then convert the feet into meters. The first table, trial number 1 was at 0.92 meters, trial number 2 is at 1.4478 meters, trial number 3 is at 1.8288 meters. And these are the results dropping the box horizontally. These are the same things, they consist of the same thing, first, second, third drop, time, weight, and they have the same height also as the first 3 trials. And this is the last trial that we did. Future applications to use this experiment for. With this experiment, we could use Galileo's theory for many new experiments. It lends itself towards a parachute design. The box that was dropped vertically had less surface area, so it had less air underneath it, while the horizontal box had more air resistance, which made it fall slower. We could also use this experiment to make new roller coasters. The width of the roller coaster could be used to control how fast the roller coaster can drop. This is the end of our experiment falling objects that we conducted. Thank you.